Good morning. So the upcoming video is on the topic of work done. Very important concept because sometimes the questions pertaining to work done involve multiple forces, and this is a question that exactly matches this criteria. Multiple forces in different directions and displacement happening, and one has to find the work done due to multiple forces and some individual forces. So let's go over to this question and start solving it. You can expect this type of question in your AP Physics examination, or if you're in India, you can expect something very similar in JEE Mains. Thank you very much. Question that I spoke about is from Resnick and Halliday, and let's start reading the question first. So the figure shows a cold package of hot dogs. I think it's very cold in India, so hot dogs make a lot of sense. Sliding rightward across a frictionless, very important, it's a frictionless floor through a distance of 20 centimeters, while three forces act on the package. So you have a distance already given to you through which the hot dog has undergone a sliding motion of 20 centimeters, and you can see there are two horizontal forces. Let me just mark them so that it's easier for us to understand where are those forces. So you can see this is one force, this is another force, these are horizontal, and the third force is angled at a 60 degree. Okay, so this is another force. So three forces acting on this, and displacement of 20 centimeter which has happened. The question number one is for this 20 centimeter displacement, and you can see the displacement has happened in x and y axis. So remember, whenever you have multiple forces, you must first establish a coordinate axis so that you have clarity as to what is the direction of the displacement. So here the displacement is in x-axis. The forces, you can see two forces are in this direction and one force is in this direction, and so you can see there is an angle between the displacement and the force 3, right? And this is where we will concentrate. All right. What is the net work done on the package by the three applied forces? The gravitational force on the package. This is the second part. What is the work done by the gravitational force? What is the work done by the normal force on the package? So okay, so there are so many forces, and in fact, I started with three, 1, 2, 3, but they're talking about the gravitational force as well as the normal force on the package. Okay, let's start with the first part and see whether. Okay, so work done is given by F dot S. Dot product is a very powerful tool to help us solve the problems of work done. Now let's pick up. So the total work done in our case is going to be sum of all these, right? So let's pick up first force. You can see is this, and the displacement is also rightward. So the angle between F1 and the displacement, both are rightwards, is going to be 0 degree, right? So F1 and S, the angle is 0 degree between them. So it's F1 is given to be 5 newtons. So 5 multiplied by 20 upon 100. I have converted it to meters into cos of 0. Plus, okay, let's go to which force? Okay, let's talk about F2. Now F2 is in opposite direction, so this is F2 and this is displacement. So the angle is 180 degrees. Okay, so this is 1 multiplied by 20 upon 100 and cos of 180. Okay, now this was a tricky part, right? You have work being done, but the angle is very important. It is something like somebody is pulling it in the other direction instead of pushing it towards the right. Now the pull is towards the left by F2. Let's talk about F3 now. Now F3, of course, you will have to resolve. As I told you, this is 60 degrees. So resolve F3 resolution of forces. This is F3, so this becomes F3 cos 60 degrees, and this is a downward force, which is F3 sine 60 degree. So you can see F3 cos 60 degree is also in the same direction as the displacement, right? F3 cos 60 is in x-axis, the displacement is also in x-axis, so the angle is 0. So F3 is how much? Let's see the magnitude of F3, 4. So this is 4, and this is cos of 60 degree, 4 cos 60 degree. And now we have to consider the gravitation. So the earth is pushing it downwards. This is the weight mg, and whatever is the surface table or whatever is experiencing a force of mg. Now you can see the direction of displacement is this, and gravitational force is in this direction, okay, 90 degrees. So the work done due to gravitation is 0. Okay, let's go to the next force. It says the normal force on the package. Now one is of course the weight, so the weight will give rise to a normal force, and then you can see there is another downward pushing force, which is F3 sine 60. That also will, so coupled with the weight, you will have an F3 sine 60 degree getting added. This is the push on the floor, and the floor will push it back with the same normal force. So the normal force is mg plus F3 sine 60, and as you can see, the normal force is also at 90 degree with the displacement. Okay, so the work done due to that also is 0. So let's calculate this now. This is 5 multiplied by 1 by 5. Cos 0 is 1 plus 1 into 1 by 5 into minus 1 plus 4 into cos 60 is 1 by 2 is equal to 5. Sorry, this is 1 minus this is 1 by 5. Okay, and this will come out to be another 2, right? So this is 2. So this is 1 plus 2 minus 1 by 5 is equal to 3 minus 1 by 5 is equal to 14 by 5 newtons. So you can see the sorry, it's joules, right? Because we calculated the work done. It's not, I got carried away because I just saw forces. It is being multiplied by the displacement. And have we multiplied the, okay, we have done a mistake here. You can see 4 cos 60 is the, but the displacement is missing, so I will just multiply this by 20 by 100. So this is 1 by 5. So in fact this will also get multiplied by, so this will become 1 plus 2 by 5 minus 1 by 5. So this will be 1 plus 1 by 5, which means this will be 6 by 5 joules. So sorry about this, I should have been careful, and I've seen a lot of students doing the same mistake which I did today, you know. So 4 cos 60 was just the force, this force, okay, the component, and should have been multiplied by the displacement. So this is your total work done by all the forces including the vertical forces like normal reaction and the weight, which essentially means 0. So this is your vertical force, this is your displacement, the angle is 90, so Fs cos 90 is 0. Let's go to the second part. Okay, B. Now B part is interesting. Okay, now work done should also result in something, right? If you do some work on a body, what happens? If the package has a mass of 2 kgs and initial kinetic energy of 0, what is the speed at the end of the displacement? So you have done a work of 6 by 5 joule on the packet of mass which is given by 2 kg, and therefore this work which was given to this body, right, results in increase of its kinetic energy, right? So the total work done 6 by 5 gets converted into half into m, which is 2 kgs into v square, and this gets cancelled, and v square is equal to 6 by 5. So v is equal to under root of 6 by 5 meters. I think you can do the calculation of 6 by 5 on your own. But I hope this question made sense to you. Although medium difficulty question, but it gives you a lot of insight into how the overall work on our body gets done when you have multiple forces. And do practice these questions where you have multiple forces. These are tricky questions, and I've shown you how to approach these questions. Take one force at a time, calculate the work done, and what is of the central idea is always focus on the angle between the force and the displacement. The angle between these two is very important, right? So if this is your force and this is your displacement, this angle will decide the fate of the overall work done. For example, in this case, F2, the work done came out to be negative because of the lesson learned in these questions is, dot product is a powerful tool. We always use it, tend to use it, and then of course when you're using dot product, keep your focus high on what are the angles between the forces and the displacement. So thank you very much, and I will come with the next video very shortly. If you like this, do subscribe to the channel and also like this video. Thank you very much.